I guess we're ready for the movie. The movie starts out, since it's highlights of STS-56, focused on the sun and the atmosphere, which is featured in our patch. And it's that quest for the sunrise over the Earth that led us to the pad B here, just after midnight. After one attempt to launch, which was aborted, we had on the second attempt a very clean countdown, solid rocket ignition, and we left the pad headed out on STS-56, the second mission to planet Earth.
Well, we cleared the tower right on time, right at the very opening of the window. And, you know, these things are spectacular enough during the daytime. And the three of us that had flown before it each had a daytime launch, and they're even better at night. We could see the reflection of the booster exhaust off of the clouds as we were in the first part of the roll. The ascent first stage is always a little bit of a rough ride going uphill, but the boosters and the main engines performed absolutely flawlessly. Here you see booster separation. It's sort of like a train wreck even in the daytime, and it's even a little bit brighter at night. It was just really a smooth ascent, and we couldn't ask for anything better.
Well, on orbit, we configured the vehicle through post-insertion, got out many of the experiments that you can see here in the background, and we had a chance to get the crew together to introduce the whole crew on orbit in the vehicle configured as a orbiting laboratory. Steve is coming out of the pilot's seat and getting into position as the three mission specialists swim into view from the middeck. There's Mike, with Ellen soon to follow. And our Redshift pilot, Taco, completing the crew of 5. This was an unusual opportunity to work a 24-hour operations flight with 5 people. So we had 3 on and then 2 on, which was very enjoyable for this payload.
Well, the reason why we were here was to watch these sunrises, which were quite dramatic over the northern hemisphere. And here you see the sun just cracking over the horizon. There's a much wider range of color when this happens, and it's quite breathtaking. Unfortunately, we can't bring it to you with the film that we have. We were looking at the sun as it rose, and we would the instruments would try and catch, for instance, the ones in the front of the bay, Atlas, there would look across and try and pick the different colors that were being refracted by the atmosphere to pick out the molecules, such as ozone and chlorine monoxide. In the back, I mentioned in the slideshow, there's Spartan. And just to the bottom left there, you can see the door of the SSBUV instrument, which is monitoring the reflected or scattered ultraviolet light from the atmosphere to monitor ozone.
And this is Oz getting ready to do one of the many maneuvers for Atlas. I think really the pilots ended up spending more time on Atlas than probably the science crew, just because we had so many maneuvers up there. And a lot of them were tied, as we've said, to sunrise or sunset. So we wanted to try to capture a sunset and just how quickly it happens in the payload bay. So Steve took this real nice picture out the payload bay during one of the sunsets, and I never got tired of watching just how quickly you could go from a very bright white payload bay to something that was extremely dark. And you can see the lid of SSBUV opening just as we go into darkness, and it was going to be doing some thermal cooling during the night in that case.
Good chunk of our secondaries were in the middeck, and here you see our boss pulling out one of the secondary experiments to do the round of daily inspections that we did on most of the locker-based experiments in the middeck and also on the flight deck. We were also lucky to have on this flight a modem which allowed us to send electronic mail messages to and from mission control, and we mounted it on the ceiling, which I wasn't really wild about using until about the second day, but here Ellen is typing away or reading a message and getting ready to send one back to Houston.
This is on flight day 4, and we're getting ready to do the Spartan deploy, and Mike took this nice shot of looking out one of the aft windows to look into the payload bay, and you can see the arm is kind of hovering above Spartan, ready to grapple it. And as I was, and Steve and I were moving the arm from the payload bay up to the release position, the orbiter was also being maneuvered because it needed to be in a very specific attitude relative to the sun for the release, because they wanted the Spartan payload to be looking at the sun when it was released. And that's looking at the overhead window as the Spartan is in the release position. And this payload was a little bit different than some others, because right at this moment of release, which you see here, Not only were we actually releasing it, but because we had no way of communicating with Spartan once it was out of the payload bay, the act of releasing it actually turned on its timer and started its program, and it went off to do its work after that. And we just had to watch it for a few minutes and watch it make a little maneuver to make sure it was working correctly.
Well, here's some more of the video, this time motion picture video of the same area that we looked at before in the stills. This is over Greece and Crete, and this is just after the first of 3 separation burns to start backing away from Spartan so that it could go do its 2 days worth of autonomous solar data gathering. Basically, the Spartan, once it left us, we had absolutely no interaction with the Spartan whatsoever. We did the 3 separation burns and backed off to just about 110 miles over about a 24-hour period, and then started a long series of burns to rendezvous with the Spartan 48 hours after deploy. We decided to go ahead and show you the whole sequence of this because it's really some of the more spectacular motion picture video that we got on the flight. Here you can see the Spartan flying over the Nile. The Nile Delta is up in the upper left-hand corner, and we just had such spectacular viewing, especially early on in the mission. About the first 5 days of the mission, the weather, as we've mentioned a couple of times, was really awesome. And we shot on the order of 7,000 different stills and all of the area film that we had on board, and came back with some really good photography. Here you see Spartan flying over the Sudan. That's the Red Sea in the upper portion of the picture. This is actually after the in sequence. We're just zoomed in a little bit closer, so the Spartan looks just a little bit bigger than it did on the previous one. We had the electronic still camera aboard, like we mentioned, and we took an awful lot of pictures of not only cities and coastal points, but also geographical features like the mountains here in the Sudan. The camera itself, the electronic still camera you saw a picture of in the stills, was connected via a series of cables, which were a little bit unwieldy, but fit right in with all the other cables on the flight deck. And they went to a PGSC, a computer that I'm using here right this minute, and it was that interface that we used to tell the Hercules which stars we were looking at, what target we were going to shoot with the camera.
This next section of the clip shows the interaction between orbiter maneuvers and the work for the science crew to do with the Atlas payload. And we caught a couple of views of some of the aft jet firings. These are primary jets. Most of the time we were on the little jets, but occasionally we had the big ones going. They were pretty spectacular. This little portable computer is what we, the crew, used to interact with the Atlas payload. We didn't have a whole lot to do with it, mostly ground controlled, but there were a couple of times where we had to help recover some situations. This is a payload bay without Spartan, and as I mentioned before, life went on with Atlas, and you can see the millimeter wave atmospheric sounder doing its little nod routine as it takes a scan through the Earth's limb. And this is the SSBUV canister with its lid open, having a look at the ultraviolet backscatter from the Earth.
One of our more complicated secondary payloads, and one of the more enjoyable for all of us, was the SAREX, or Shuttle Amateur Radio Experiment. Here you can see me configuring the main equipment housing, and then Taco was in contact with amateur radio operators in Australia who had linked him through telephone lines to his home and was able to share a few moments conversation with his family. In another opportunity, Steve, over in the commander's seat, is on the radio speaking to students in Bellingham, Washington, and that happens to be the school mascot from his hometown there in Bellingham. Flight day 6, after we'd done a lot of Atlas operations, it was time to get back and get the Spartan payload. You can see the crew of all 5 is assembled, and we did a series of maneuvers, fired the jets to get the orbiter back into position to capture the payload. So we transitioned from operating out of the forward cockpit to going to the aft flight deck. That's about the time we began to pick up visual sight of Spartan. And it was very easy to see. And here, looking through the crew optical alignment sight, you can see Spartan as that bright white dot in the upper right quadrant of the sight. At about 1,000 feet, we got a little bit more detail as we zoomed in the cameras. We began to pick up the idea that was in attitude and stable. And as we continued to close, we began to lose the ability to track it with our radar. And you can see Mike there using the handheld lasers to get information on its range and range rate. And that allowed us to maneuver finally close enough for Ellen to grab it.
This is what the picture looks like from the camera that's mounted on the end of the arm. You can see when I took over, it was pretty much right in the center view, just had to roll a little bit. It was really a great rendezvous, and it was very easy as an armor operator to come right in, line up on that target that you see there, and use that to capture the Spartan. Then when that was done, the next thing to do was to berth it back into the bay in the same place that we had pulled it out from. And finally, Steve threw some switches that enabled these motors to latch it, and we wanted a way to determine when it was really latched. And there you see it. That was the source of Ken calling down that we had 6 smiling faces on board after we finished the latching.
Taco and I were on the Redshift, and we spent quite a few hours on our own up on the flight deck. But here on the middeck, we would meet the other shift and maybe not quite share a meal together, but spend some time. And I actually had some time to capture Ellen recreating, playing her flute here. And she's an accomplished flautist, as you can see. And she serenaded us with tunes from various military hymns. Demonstrating some physics here, water behaves quite differently in orbit. Surface tension dominates everything that liquids do in space, in free fall. And here we put out about 12 ounces of water, and I could tell that Ken, our commander, was a little alarmed that I was doing this, but we kept control of the water, we didn't spill a drop, and having squeezed it out of a drink bag, we were able to suck it all back up and drink it. And in this way, we could prove to the doctors that we were well fluid loaded and paying attention to drinking a lot each day. And this is just a typical housekeeping scene. Is Ellen and Steve, and they're loading a Nikon F4. We use 35mm cameras basically for in-cabin shots. And as Steve mentioned, we used almost all of our film on this flight. And we were able to load these cameras in a matter of seconds and then get straight back to shooting each other.
Is a motion picture clip that sort of gives you a concept of what we're after with the Earth observation still camera views that we took so many of. This is in the Indonesian area, which is an area where Mike and I were awake most often during the daylight. And this is going down the southwest coast of Sumatra. We may not always see the points of interest in the photographs that we take, but meteorologists, oceanographers, and people that are looking at land use around the world can get a lot of information from what we've taken. Here it shows a number of river valleys on the way to leaving their silt and deposits in the Indonesian Sea just off the coast of Sumatra. And there's a little bit of sun glint. There's some better sun glint in a future shot that we're going to see, and some of the cloud patterns. We were mostly in an upside-down airplane mode for a lot of the flight, so the forward windows turned out to be pretty good ones to look at the Earth from, and there Mike is craning his neck to get a good view. This is the northeast coast of Australia, just around the vicinity of Sydney, looking back to the north. And although there's not a whole lot shown up in this, the sun glint really aids in viewing changes on the ocean surface due to temperature, for example, El Niños, or major currents, or even major tides can be shown up very well with the sun glint.
Well, here's Steve preparing food in our galley area, just towards the forward part of the middeck. Of course, it's not just a kitchen, it's not just a washroom, it can also be a gymnasium. And we had 2 devices for exercise on board, an ergometer, basically a bike, in which you can see Ellen here exercising, and also a rower, and you can see Steve there pulling hard. And all he's doing is he's got his feet anchored down and he's pulling on this T-bar with a cable attached to it. And this is a pretty interesting shot where they're both working out together. At the end of the day, each shift had to switch out these canisters that contain a chemical called lithium hydroxide that absorbs the carbon dioxide that we've exhaled during the previous day.
I think we're just about getting ready to put the arm away here. And for most of the mission, while we were not actually using the arm with the Spartan, we had the arm in an extended park position up about 160 degrees of yaw up forward of the nose, so that it would be out of the way of the Atlas payloads that were looking at either the limb of the Earth or the Sun. When we got ready to come home the first time, we put the arm away and left it cradled for the duration of the mission. And I guess our families would like to think that we were all ready to come home and everything, but probably the greatest thing that happened to us was getting a wave-off day for weather and getting a chance to stay on orbit for another day. It had been a pretty hectic pace there, and we were all just a little bit tired out, and the wave-off day gave us a chance to rest up a lot. We got a chance to look out the window and shoot up what little film we had left, and really get a chance to enjoy being in space. In fact, we joked around that we probably had to plan one of these wave-off days into every flight, and really get a chance to enjoy the environment. Here we are on the middeck on day last, and floating a dried apricot around. This gives you an idea of the view out the windows that you get with the aft-facing windows and the view out the overhead windows, and just a final sunset on the Spartan mission here. This was about the 147th one that we saw, or something like that, during the flight, and just never got tired of looking at them. But eventually, on the next day, they said it was the weather was good at the Cape. We worked a lot of weather problems on the first day and chose to wave off. The second day, we had a big tailwind pushing us, and so we were a little bit concerned about that. The flight control team gave us a good briefing on all that, and we had some wind problems that we were looking at down in the lower levels. But this film that they got from a camera located down near Patrick Air Force Base is some of the most spectacular entry film that we've ever seen. You can see the vortices coming off the wings as Ken is rolling the vehicle onto the hack. Speed brake is open full, and the vortices basically being shed all the way around here, and a tremendous visual scene that you get. We're pulling about 1.6 Gs during the initial part of that hack turn and backed off to about 1.4. Ken was right on the hack, right on all the energy numbers all the way around, and it was just a beautiful job of flying the airplane.
Well, once we completed the turnaround to heading alignment circle, we were in the usual steep dive towards the runway. You can see here from another camera view, I think on top of the VAB, zoomed in, the orbiter comes down pretty steeply compared to your average airplane. And we had good sight of the runway environment. The weather was very good except for some headwinds that were down at the 3,000 to 4,000 foot level that presented a possible problem when you consider that we're flying a glider. We coped with those thanks to some help from the ground and briefings we got from the STA pilots. The landing gear came down at 300 feet, and then you can see here as we made a few last corrections to attitude and set ourselves up on the center line for a touchdown. Main gear touchdown because the two tires spin up. And then we hold the nose up long enough to allow the vehicle to decelerate. We use the drag of the undersurface to help slow us down. And Steve deployed the drag chute, which we showed earlier on the still photograph, as we derotated or lowered the nose down to the runway. The drag chute opens up fully, and that provides a lot of deceleration, which we were not short of runway today on that particular day, but it gives us a lot more margin on our brakes. As we get a little slower, we separate the drag chute or jettison it, and then braking and steering returns the vehicle to a complete halt. And that was the close of, I think, an outstanding mission to be a part of, the second of what I hope will be a long series of Atlas missions to study the environment and the sun's energy which influences it.